Okay, so it's solving absolute value inequalities. So before we start that, let me go off on the side here and just talk about how we did these in chapter 2. You don't have to write this part down if you don't want to. But in chapter 2, we had a problem, maybe something that looked like, I don't know, let's see, the absolute value of x plus 3 is equal to 10. You remember those? Remember how you had to get two cases? You remember does anybody know what the two cases were? Well, the first thing you had to do, remember, is you had to get...
X equals 7 or X equals -7?
That's one of them. First thing was you had to get this symbol by itself, right? So you had to get the absolute value by itself first. But then, what did we do after that? How did we set up the two cases? One of them was definitely x plus 3 equals 10. What was the other one? X plus 3 equals... There you go. So the second case was x plus 3 equals the negative of 10. So, again, in both of these cases, we drop the absolute value. Notice there's no absolute value in here. We write the first one pretty much just as it is. Just as it is here. But the second case, we take the negative of that number on the right-hand side. And then we solve both of those, right? Now, the only difference today is it's not going to be an equal sign in there. It's going to be like it could be like a less than or equal to. So that would be the only difference. Well, in this case, when you take these out of here and you drop the absolute value, the first case is you kind of do it just like you did before. You kind of rewrite it exactly like it would look without the absolute value. But in the second case, you have to flip the absolute value the other way. So that would be your two cases. So one of them is the same as the original. X plus 3 is less than or equal to 10. The second one is x plus 3 is flip it and then take the negative of that number on the right-hand side. And then we'll get into more of the details here in a second. But that's what we want to fill in on this first blank. Oh, I lost it. On the first blank here. So what they're talking about in this, where we fill in the blanks, they're talking about that second case. So in the second case, we change the sign to negative. So that number on the right-hand side, we take the negative of it. And we flip the inequality symbol in the middle. Now there's something else I want you to notice on here though. And this will get important when we do the examples. Is notice that when this is a less than, then the problem is an and. And when it's a greater than, the inequality is a or. That's going to be important. Now this one over here, this could also be a less than or equal to. And this one over here could also be a greater than or equal to. So if it's got a less than in it, it's going to be an and. If it's got a greater than in it, it's going to be a or. So let's try some of the examples. So go ahead and turn the page. So here's example 1. I don't know what happened here. Oh, there it is. Oh, that's weird. My page didn't turn. You guys are going to have to hold on a second. Maybe I don't know if it's just the internet slow or what.
I think your page just mentioned.
Because that's the previous page still. So, Let me go back out and go back in and see if I can get it to switch to the right page. Let's see. There we go. Now it worked. All right, here we go. So now we're on example 1. So what's the first step on all of these, you guys? Do you remember? Well, not just get the x by itself, but get the absolute value by itself. Okay, so the first step is to always make sure that this symbol and whatever's inside of it is the only thing on one side of the inequality. So I don't care what's inside of it, but just you got to get the absolute value all by itself. So how do we get that all by itself in this case?
Add 3.
Yeah, we could add 3 on both sides. So that's always the first step. So now we have the absolute value of x. Let's see, how much room do I got? I'll probably go here. So I got absolute value of x on the left. Those cancel out, make 0. That's less than, on the right-hand side, I got -1 plus 3, that's 2. So after you have the absolute value all by itself, now the next most important step is you got to decide, looking at this now, is that an and or an or? So look at the, yeah, if it's got a less than in it, it's an and. So you got to note that. But don't do that until you get the absolute value all by itself first. All right, and now that you know you got it all by itself and you know that it's an and, you guys are just going to set up your 2 cases. So you're going to take the x out, or drop the absolute value symbol and kind of write it just like it is. X is less than 2, and then we're going to drop the absolute value symbol again and make it, what do I got to do? Somebody raise their hand so I can call on somebody. What? How would I, yeah, Neve? Negative what? Not a negative x. Negative something. Yeah, -2. So I got to make the 2 negative, and then which way does the inequality go?
Greater than?
Yeah, I got to flip it the other way. It's a greater than. You guys see it? So these are the same, except this is flipped, and we take the negative of that number on the right-hand side. All right, well, that one's already, that's pretty much done. But do you guys remember it's on the top of your previous page of your notes? What does and stand for?
Like the stuff in between, the double shaded.
Yeah, double shaded part. Good. Yeah, so when it's an and, right there, when it's an and, you're looking for the intersection. That's the word I was looking for. So when it's an and, this is an intersection. All right, so then we're just going to graph both of these and look for the intersection. So let's do a couple different colors here. So in blue, we got this one. So, well, there's 2 numbers that I need on my number line, right? I need -2 and +2. So let's put -2 and +2. All right, and then looking at that blue thing right there, is that an open circle or closed? That's open and shaded to the, yeah, let's get a bigger response. All right, on the next one. So open to the left. So that's going to be open to the left. All right, and then the other one, let's do it in green. So for this one, let's get everybody to respond. So this one, open or closed? That's not everybody.
Open.
Cameron? Thank you. Yeah, open, shaded to the, good. It's the x is greater than -2, so that would be the numbers to the right of -2. So it's open. So we need open, shaded to the right. Okay, well, we're looking for the intersection. I don't know if you can read that very well here, but that's what that says right there. So if we're looking for the intersection, we're looking for the double shaded part. So we're looking for the part that's blue and green. Where is that? Where's the part that's blue and green?
It's in between the two. It's in between the two.
What do you guys got? Where's the part that's blue and green?
In between the two twos.
Yeah, well, in between the -2 and the 2, right? So that's going to be our solution, is the part that's double shaded. Now, usually I should have used a different, I should have drew a number line for like our scratch work, but our final graph needs to look like this. I didn't do it this time. Our final graph should have a -2 and a 2 with an open circle, and shaded in between. So that's our final graph right there. And then how do we write that solution? Remember there was a way to write that all in one statement?
X is, or -2 is less than X is less than
Yes, that's perfect. Yeah. Rachel, that's good. So what we want to do again is we want all these X's in here. Those are the solutions we're looking for. So those are the X's that are in between -2 and 2. So we actually write X in between -2 and 2. So just put the number on the left as -2, the number on the right, the number on the left is -2, the number on the right is 2. You just put X in between, and then it's always a less than, less than. All right, so that's the other part of our solution, is that right there. So that part is writing the solution, that's the inequality, and then this part is the graph. But again, they both mean the same thing. Let's try the next one. So here's number 2. Is the absolute value all by itself? Yeah. Yeah, the only thing on the left-hand side is just this thing, right? So that means we can go right to the 2 cases. So again, the first case, we're going to drop the absolute value and write it kind of just like it is. So X minus 1 is less than or equal to 2. And because we got it by itself, we can look at this also and decide, is this an and or an or? Is it an and or an or?
And.
If it's a less than, it's an and. So we got that for sure. So we're going to write and. Okay, now somebody raise their hand, who can tell me the next case? Rach, I know I got to get somebody else. What's the next case look like, you guys? Dewan? All right, so I heard the X minus 1, and I heard the -2, but which way does the symbol in the middle go? Dewan, do we flip it or do we leave it the same? Yeah, we flip it. So it's going to be greater than or equal to. And then we just got to solve both of those. Well, these are pretty straightforward to solve, right? We got to get X by itself. So we're going to add 1 on both sides. On both of those inequalities. And then we got, let's see, on this side, those cancel out, make 0. So we got X on the left, and that's less than or equal to 2 plus 1 is 3. And on this one over here, those cancel out again. So we got X on the left, and that's greater than or equal to -2 plus 1 is -1. So now this time I am going to draw a number line that's like kind of like my scratch work, okay? So my scratch work on this, I'm going to just make a number line real quick. And I'm going to put the 2 numbers on there. Again, it does not need to be to scale, but they do need to be in order left to right. So I'm going to put -1 on the left and 3 on the right. Okay, then let's do this one in blue. So then what about this one? Open or closed? That is closed, shaded to the... All right, thank you, Sid. Yeah, so that's at 3. So we got a closed circle at 3. Shaded to the left. All right, and then we'll do the other one in green. So the green one, open or closed? Yeah, it's closed. It has the equal to bar, so it's closed. Shaded to the...
Right.
Thank you. And again, it's an and, right? That's very important. After you get this absolute value all by itself, then you need to know whether this thing is an and or an or, because if it's an and, you're looking for the intersection or the overlap. So where's the overlap?
In between -1
In between -1 and 3. So we're going to put, now this is going to be our final graph, okay? So we're going to put -1 on there. So -1 and 3. All right, and they're both closed circles. Do you guys see that? So we got a closed circle at -1, we got a closed circle at 3, and we shade in between. So that's our graph. And then can somebody raise their hand? Let's take a shot at how do we write that statement then? Neve? Yeah, good. And then do we need the equal to bars? Yeah, because of the solid dots, right? So that means our solution would include the -1 and the 3. So yeah, you do need the equal to bars on this one. So that's your solution right there. And then your graph is right here. And then how do we check our answers for this stuff? Anybody got an idea on that? How do we check our answers? You guys should be writing this stuff down, right? They can use this on the test tomorrow.
You just plug in like
We need to plug in a number. What do we plug in?
Either
3 or -1.
Or anything in between there, right?
Yeah.
So we could actually plug in, give me a number between here and here. 2. So we can test 2. Now I'm not going to write all that out. And then where would we put that 2? Where would I plug in the 2 to check to see if we did the problem correctly?
In for X.
In for X in which one?
Either
Which one?
either one.
Actually, you need to go in the original one. Remember, we're finding the X's that make this inequality true and this inequality true at the same time. We're going to plug our X into here to see if we did it correct. We're going to put it in the original inequality. So that means you guys said pick 2, right? So 2 is definitely in that shaded region, so we're going to put 2 in right here for X. So what's 2 minus 1? That's 1. What's the absolute value of 1?
1.
Yeah, that's 1. Is that less than or equal to 2? Yeah, so it checks. Okay? Now we got a couple more examples to go, and then the last 2 will go quick, okay? All right, so let's do number 3. So number 3 is, the first question always is this absolute value all by itself?
No.
So how do we get rid of that plus 14?
Subtract it.
Yep, so subtract 14 on both sides. And that'll give us the absolute value of X is greater than or equal to 19 minus 14 is 5. Now, do I need to flip it? Like, did I need to flip it when I subtracted 14 on both sides? Here? If I do that, do I need to flip that the other way? What's the only time we flip it? If we do what with a negative number? Yes, if we divide or? No, we just subtracted. We just subtracted 14 on both sides. We didn't have to flip it. So what's the only 2 times we flip the inequality? Lucas, that's good, yeah. If you multiply or divide both sides by a negative number, then you flip it. So we're not going to flip it. Now we're just going to break it into the 2 cases. Oh, before I do that, now that I get it by itself, I almost forgot this. So now that the absolute value is by itself, is this an and or an, oops. Is this an and or an or?
Or.
Yeah, that one's an or. So if it's got a greater than in it, it's going to be an or. Now, look back on that previous page of the notes. What was an or? It's up at the top of the previous page. It's a union. And a union, I had you guys write down, that's anywhere that's shaded, right? So our solution is going to be anywhere that's shaded because it's an or. Well, let's break it into the two cases now. So I drop the absolute value and set this thing greater than or equal to 5, or I drop the absolute value again and I flip it and take the negative of the number on the right-hand side. Like that. And those are basically done, right? I just got to graph them both. So again, we'll do in the blue here. Everybody, open or closed? Closed. Shaded to the right. Good. All right, let me put my two numbers on my number line first. This one, I'm going to go ahead and put it right on the number line. When it's an or, I'll put it right on this thing. So here's -5. Here's 5. All right, so we got you guys said close to the right. So close, oh, I'm in the wrong one. Close to the right. So at 5, I'm closed and I'm going to the right. And then the other one, we'll do that one in green. So this one, the green one, open or closed? Yeah, come on, it's got the equal to bar and it's got to be closed. So it's closed and shaded which way? Yeah, this right here, this says x is less than or equal to -5. The numbers that are less than -5 are to the left. So it would go this way. All right, well, again, on an or statement, I'm looking for the solutions that make this inequality true or that make this inequality true. So I don't have to, there doesn't have to be an overlap. That is the answer. Anywhere that's shaded when it's a union, okay? If it's a or, anywhere that's shaded. So this is our final graph. Oops, I didn't want that color. So this is our final graph. And really up here, this was our solution. Our solution is right here. We can't write it all as one statement like we did on the other ones. Because they're two, you guys see that? When it's a between this statement, when the graph looks like this, when it's all the x values in between two numbers, that's when we can write it as a between this statement like that. But when it's an or, this is our answer right here. All right, so we got one more to go. And then the last two will go quicker. Okay, so this one, somebody raise their hand, tell me the first step. What about if I call on somebody? Adrian, what do you think? We got to get the absolute value all by itself here. Adrian, what do you got?
It would be
Wait, what's the first step?
equal with,
We got to get rid of this somehow, this thing.
okay, so it would just be x plus 5.
Well, how do we get rid of that 3 right there?
Well, we subtract.
There you go. Yeah, we subtract. So we're going to subtract 3 on both sides. And now we're going to have the absolute value of the quantity x plus 2 is greater than 2. All right. Now that we got it by itself, we have to look at this thing right here. Is it an and or an or? That's an or. So as soon as we know that it's an or, we got to start thinking about, we're looking for anywhere that's shaded, okay? It's a union. And then I'm going to write the two cases. So the first case is going to be x plus 2 is greater than 2. And again, notice we drop the absolute value symbols when we do this, right? When we break it into the two cases, drop the absolute value, drop it again. And then who can, again, raise your hand, who can complete that statement for me? Logan? is less than, that's good, you flipped it. What else? One more thing. What kind of 2? Yeah, negative 2. Good. And then we got to solve both of these. But again, to solve both of these, we're just going to subtract 2 on both sides. We're just trying to get the x by itself. So those cancel out on the left. We get x is greater than 2 plus negative 2, that's 0. Or the other one, these cancel out, and on the left you get x, and on the right you get negative 2 minus 2 more. That's negative 4. All right, and then again on these, that really is our solution right there, okay, when it's an or. So our solution is going to be this. And the graph we're looking for is anywhere that's shaded. So for this one, open or closed? That's open at 0, shaded to the right. So let's put our 2 numbers on there first real quick. So we need 0 on there and negative 4. So negative 4 and 0. And again, I don't care about the scale, but those things do need to be in order left to right. So greater than 0, you guys said it was open. Shaded to the right. All right, and then the next one, x is less than negative 4. So this one is at open or closed? That's open to the left. All right, those are the x's. Again, if you're going to be less than negative 4, you have to be to the left of negative 4. So this is open, shaded to the left. All right, and then that's our graph right there. That is our graph of our solution. Again, we're not looking for the overlap when it's an or. We're just looking for anywhere that's shaded. So let's see. Let's do a check on this one real quick. If we want to do a check on here, somebody give me a number in the shaded region.
1.
5.
1 would be in this one, right?
Yeah.
Negative.
Hold on. 1 would be, we'll do another one in a second. 1 would be in this shaded region right here to the right. So 1, we're going to take that and put it in the original inequality right here. So what's 1 plus 2? 3. What's the absolute value of 3? 3. 3 plus 3 is?
6.
Is 6 greater than 5?
No, I meant yes.
Yes.
You said no. I swear to God.
Yeah.
What does it mean?
So that works.
Definitely the 1.
All right.
Gross.
Then Matt, give me a number over here.
Negative 2.
You're not Matt. Yeah, negative 5.
Yeah.
Negative 5.
360.
All right, negative 5. Put negative 5 in right here. Negative 5 plus 2.
Negative 3.
Negative 3. Absolute value of negative 3.
3.
3 plus 3 is?
6.
Is 6 greater than 5?
No.
Is 6 greater than 5?
Who said no?
I mean, it's obvious.
Yes. Yes, it is. So that's how you check them, okay?
Okay.
Notice that it could be a solution to this inequality, or it could be a solution to that inequality. It didn't have to be a solution to both of them at the same time. All right, and see anything else we're missing? All right, let's look at 5. So we got 3 more to go, but these are a lot quicker. So let's look at 5. Is it by itself?
No.
No, here it is right here. The absolute value is not by itself. How do I get rid of that minus 5? Thank you, Ryan. So we're going to add 5 on both sides. So we get the absolute value of x plus 4 is greater than negative 3. Now, you notice anything weird on this one?
It's a negative number, so it's not.
Yeah, it's a negative number. What do you know about this side? What does this always have to be? Let me move that absolute value symbol there a little bit. What does this left-hand side always have to be? This thing.
X by itself.
I mean, what is that? When you take the absolute value of something, it's always what?
Greater than instead of positive.
It's positive. So that left-hand side is positive no matter what. It doesn't matter what quantity is inside there. The absolute value of anything is going to be positive. Is a positive greater than negative 3? Yeah. A positive is always greater than a negative, right? A positive is always greater than a negative. So that is always true. So that's always true. So then what's the solution?
All real numbers.
Yes, when we get a true statement, the solution is all real numbers. So you can either write infinitely many solutions, you can write all real numbers, or remember you can make this symbol. Now if you wanted to graph that, it'd be kind of, I mean you don't have to, but you would shade in the entire number line, right? If you're going to graph all real numbers, you shade the whole number line in. Well, that means any number you pick is a solution to that original inequality up at the top up here, this one. The one with the absolute value in it. So that means any real number will work. It could be a fraction, it could be a decimal, it could be a square root, it could be whatever. Somebody give me a number.
Negative 630.9.
Why?
Why not?
Let's just try negative 600, okay, just to make it simpler. So here you go. So we're putting negative 600 in right here for x. Guys, negative 600 plus 4.
604.
No, negative 600 plus 4.
Oh, 596.
Negative 596, right?
I didn't hear you say negative. I'm sorry.
It would be
What?
it'd be a negative 590. Hey guys, remember I'm recording, okay? So this would be negative 596. What's the absolute value of that? What's the absolute value of negative 596?
596.
That's 596 minus 5. What's 596 minus 5? Say it again, 596 minus 5?
No, wait.
591. Is 591 greater than 8? Or sorry, greater than negative 8? Yeah. Yeah. Yeah, so you could put any real number in that thing. All right? Now, let's say you didn't notice that. All right, I'm going to work this out really quick for you guys. Let's say you got to this step right here, and you didn't notice that it was a positive is always greater than a negative number. And you just went through and tried to work it out. So I'm going to do it real quick. So the first case would be x plus 4 is greater than negative 3. And this one would be, would this be an or or an and? That one's an or. So when it's an or, we're looking for anywhere that's shaded, right? Okay. And then the other case would be or x plus 4, flip it, and take the negative of that number on the right-hand side, which would be a positive 3, right? So I flipped it, and I took the negative of the number on the right-hand side. Now, if I subtract if I solve both of these for x, this one is x is greater than negative 7, or this one is, subtract 4 on both sides, this one is x is less than negative 1. Now, let's think about what that graph would look like. Let's see, at negative 7, I'd have an open circle shaded to the right. And at negative 1, I'd have an open circle shaded to the left. Remember, an or is anywhere that's shaded. What's shaded on this graph? Or is anywhere that's shaded. What's shaded on this graph? Doesn't matter if it's single shaded, double shaded, just anywhere that's shaded. Everywhere. Who said that? Matt, that's good. Do you see that this is shaded everywhere? I mean, on the one, we're missing, on this one right here, we're missing the negative 7, right? Because it's an open circle. But we pick up off of this one, we pick up that shaded region right there, and that picks up the negative 7. So yeah, the entire number line is shaded in. Do you guys see that? If it's an or, it's anywhere that's shaded, and the whole thing is shaded. That's what I just said right here, right? The whole number line is shaded in. That's why the answer is all real numbers. So if you didn't happen to notice that a positive is always greater than a negative and come up with the fact that the answer was all real numbers, if you went through and worked the problem out, you'd still get it. because the or is anywhere that's shaded. Let's do the next one. We're almost done, guys. And we'll take a bathroom break, all right? All right, now. That one's all real numbers. What do you think the next one's going to be?
False.
What's that?
This one's not.
Yeah, probably going to be no solution, I would guess, the way things usually go in the no packet. So let's try this one. Is the absolute value all by itself?
No.
No, so what do we got to do?
Subtract 9.
Good. Was that you, Cameron?
Yeah.
Thank you. So now we got the absolute value of x minus 2 is less than negative 2. The right-hand side would be 7 minus 9 is negative 2. All right, so now we know there's something weird going on here, right? Because we got that negative on the right-hand side. And we know that this left-hand side is always going to be a positive because the absolute value of anything is always positive. And now look what this thing says. This thing says a positive is less than a negative. Is that true or false?
False.
That is false. This says a positive is less than a negative 2. Well, a positive is never less than a negative. So that's false. So a positive less than a negative is always false. So this is always false. All right. So then how many solutions? None. So you can write no solution, or you could write this thing, right? Now again, just real quick, let's pretend I didn't notice that. And I'm going to set up the two cases real quick. The first case would be x minus 2 is less than negative 2. We didn't decide. Is this one an and or an or? Good. That's an and. So then we would have and our second case would be x minus 2. Flip it, and take the negative of the number on the right-hand side, which would make it a positive 2. Now, if we solve both of these, we're going to add 2 on both sides, right? We got to get x by itself. This one would become x is less than 0, and this one would become x is greater than 4. So I got 0 and 4 on my number line. They're both open circles. I got x is less than 0 goes this way. And I got x is greater than 4 goes this way. It's an and. When it's an and, I'm looking for the intersection. So I'm looking for the double shaded part. What part of this is double shaded? What's that?
None.
Yeah, none of them. Right? We are looking for a double shaded region. We're looking for an intersection or an overlap. There isn't one. Well, that means how many solutions are there?
None.
None. That's why we got no solutions. All right? So even if you didn't notice it and you went and worked it all out, it should work out in the long run that there is no intersection on this one. It's an and. It's supposed to be an intersection, and there is none. All right. Let's see. We got one to go. That's it. And then we'll go on a restroom break. So hang with me. Let's get through this last problem. I know this is a long lesson today, but... So here we go. So this one says the recommended temperature for a baby's bath is 95 degrees, but it says it's acceptable for that temperature to vary by at most 3 degrees. So you guys already know the answer to this before. We're supposed to set up an absolute value inequality for this problem. What's the highest the temperature could be?
98.
98. And what's the lowest it could be?
92.
92. So we're looking for an answer of the temperatures being between 92 and 98, including 92 and 98, right? So we got to just figure out how to write an inequality that'll do that. So now if you think back to chapter 2, again, hang with me, we're almost done. This is going to be an absolute value inequality, so we need an absolute value. And inside there, we're going to put the difference between the actual temperature and the recommended temperature. So really what we're trying to do is we're trying to decide like in these two spots, there and there, where does the 3 go and where does the 95 go? Does the 3 go inside the absolute value or does it go outside? What's that? Well, if you remember back from when we were doing this, the number that goes out here is how much it varies by. Yeah, the 3 goes out there. All right. So the 3 is going to go out here. Oops. All right, well, that means the 95 goes inside then. So inside the absolute value, we have the difference between the actual temperature and the recommended temperature, which was 95. And then the other key word we need in here is right here. It says at most. So what does at most mean, Duan? Good. Yeah, it's less than or equal to. So this has to be a less than or equal to. Now from here, I think we can go pretty quick. That's our inequality. That's the thing we had to write right there. And then is this one an and or an or? Yep, it's an and. So an and tells us that we're looking for an intersection. All right, let's just set up the two cases. I don't think, well, we'll graph it just to solve it, but let's just set them up real quick. So we got t minus 95. We drop the absolute value and we write it the way it is. And we drop the absolute value again, t minus 95. Then we flip it and take the negative of the number on the right-hand side. All right, then we just got to solve both of these. So we would just add 95 on both sides on both of these. All right, so these would cancel out and make 0. I got t is less than or equal to 3 plus 95 is 98. And the other one, these cancel out. On the left, I got t is greater than or equal to negative 3 plus 95. That's the same thing as 95 minus 3. That's 92. And we're going to draw a little number line here. And we're looking for what? We're looking for the overlap. Good. So we'll make our little number line, put the numbers in order on there, left to right. So, oops. So 92 would go here on the left. 98 would go on the right. This one in blue, that's a closed dot to the left. Make sure you go past the 92. And this one over here, that's a closed dot at 92 going to the right. So again, it's an and. So we are looking for the intersection or the overlap. So we're looking for the part that's green and blue. Where is it? Yeah, between 92 and 98, including the 92 and 98. We already knew that was the answer before we started, right? But then who wants to take a shot? One last thing I'll call on you for. Raise your hand. How do I write that statement? Neve, what do you got? 92.
Is less than X.
Good. Yep, good. And then don't forget, this one has the solid dots. So you got to put the equal to bars on there. Yep. So you put the equal to bars on both of those. And that's it.